a second. It's taking its time. All right, I think let's kick it off. So yeah, welcome everybody to our first online Melbourne/Australia/New Zealand LabVIEW User Group. It's been a long time coming. We've been meaning to get back into some regular events and COVID kind of killed it for a while there, but yeah, we've sort of put a plan together to get it reinvigorated. And since technology is a bit better these days, we can do it online, which is even better. So yeah, we'll Stuart, do you mind just if people are coming in, can you admit them if possible, please?
Yep, not a problem.
Thank you. So yeah, so today is about just getting the local, regional Australian New Zealand LabVIEW User Group back up and running. And yeah, we're pretty excited to do that. So the agenda today, two things. First of all, I'm just going to give you a bit of a plan for what we're doing for the rest of the year. And also we're going to let you in on some developments that a few of us have been working on in the background. So we'll let you know about that in a minute. So that's going to take 5-10 minutes, hopefully not too much longer. And then after that, we've got Brett Percy, who's going to present on what's new in LabVIEW in 2022. And so I'm looking forward to seeing that because I haven't really had a chance to play with 22. So that'll be good. And yeah, welcome again. Thanks for joining us. And let's make a start. So I'm going to fire up my screen here. All right. Oops. So, all right. So, yes, online Australian New Zealand User Group is a bit of a mumble of a name at the moment, but normally we run the Melbourne LabVIEW User Group here in Melbourne, but I wanted it to be more than that today. So let's talk through the plan for the rest of the year. So today we're just sort of kicking things back off with an online event, really looking forward to getting everyone re-engaged in the community. If you're living under a rock and aren't aware, there is a GLA summit coming up in November. So really strongly encourage everyone to sign up to that. It's a 24-hour event happening from 12 p.m. UTC time, I believe, on the 14th of November. Correct me if I'm wrong on that timestamp. And it goes for 24 hours and it's all online and it's all free. And it's a global event. So it's been running now for a couple of years, thanks to COVID, but they've kept it going. Why not? My team and I will be sitting here in our boardroom watching a few of the events and sessions on one of the days, and it's a great way for the team to get together and learn about some new stuff. So go to glasummit.org and please sign up. And I think they're short on some presenters, especially in our region. So yeah, please put your hand up and you know, put a presentation submission in. I think anything will fly at the moment in our region because they're a bit low. So yeah, it'd be awesome if you could get involved. And then what we're planning to do on the 7th of December is we're going to have an in-person LabVIEW User Group here in Melbourne. We'll probably live stream that as well. Nominally 7th of December, 6:30 p.m. And it'd be good to get an in-person event happening again. So more details to come on that. Yeah, so and then we're going to plan out 2023 in the coming months. But what you're all waiting to hear about is what we're planning, the big one. And that is we're hoping to get GDevCon flavour for Australia and New Zealand happening here in Australia. Now, it's really early days, and but we've got a working committee sort of established. If you're interested in participating or helping out with this, please reach out. We'd love some support or some volunteers to help move this along. But GDevCon, if you're not aware of it, is it's quite a popular development conference for LabVIEW developers. it started in the UK in 2018, and North America had a couple of GDevCons in the past year and last year. And we thought it'd be awesome if we had a flavour of our own down here in Australia and New Zealand region. So if you don't know what GDevCon is, it's a independent developer conference for LabVIEW, and it's all about learning and practicality. And yeah, I'll come to the next slide in a second, tell you more about that. But before I go any further, I really want to just draw your attention to this survey here. We have a survey out there. We've got some responses so far, but I really would love to encourage you, if you haven't already, please jump on to that URL right there. And I'll put it in the chat in a second as well. We'd love your feedback, right? We're trying to gauge, you know, whether there is the demand for such an event here in this country and or this region, and you know, and what sort of stuff would be more valuable to the LabVIEW developers in our area, because it might vary quite a bit from what you've got here compared to North America or Europe. So please, if you haven't already, it's only a 5-minute survey, won't take too much time, and really love your feedback. I'm going to copy that right now into the chat so that you've got that there. All right, so let's move on. So what is GDevCon? It's going to be a paid conference focused on graphical programming, i.e. LabVIEW. It will be a group of practical presentations structured around you being able to apply stuff quickly and immediately. So it's all about practicality. It's not about, that's the focus. It's not necessarily about often the future possibilities. This is about how can you guys apply this stuff today and make a difference. They call it the user group of user groups. So it's really an opportunity to learn from your peers as well as other experienced developers. We'll be aiming at all levels, from beginner through to expert. There'll be a few sponsorship shout outs, but it's not going to be sales pitch based. It's really about practicality and learning. It's also one of the other GDevCon mantras is bring the team, and bring your whole development team to the conference and learn and grow together. And one of the other things I love about GDevCon and GDevCon NA is the great videos that come out on YouTube afterwards. I think that's an awesome thing for the community. Great quality video and a great opportunity for all of us to learn if we don't get there. The benefits of having that here in Australia, we see it as threefold, but we want to have a conference that's very specific to the Australian and New Zealand industries, which might differ from what's going on in the rest of the world. So we want to try and customize it a little bit. But the big thing is to sustain and grow this community. The LabVIEW community, COVID's changed things, NI distributorship models have changed. So it's a little bit on us to keep the community alive and learning from each other. So it's about sustaining that. And and committing to the local economy and providing a real career path for our graphical programmers. We want people to know that when they get into LabVIEW, it's a career for life if they enjoy it. So yeah, once again, the survey. Please jump in and fill in the survey. Can't emphasize that enough. It really helped us out. So that's just GDevCon ANZ, and it's very early days, but we're excited to get something up and going. It probably is going to be early 2024 by the time we get organised, and yeah, really keen to see what you think and let us know if you want to contribute. At this point, before we move to the Brett's presentation, I'd like to just see if there's any questions on that. going to stop sharing for a second. Darren had a comment. So thanks, Darren, for commenting that you were presenting 3 times at GLA Summit. That's awesome. We're doing one presentation.
Chris, quick question with GDevCon. Are we inviting overseas guests to present at GDevCon?
I guess we haven't made a call on that, but that's certainly we're open to doing that. It's open to everyone, definitely. And I know a couple of my LabVIEW friends around the world are interested in maybe coming over. So yeah, let's.
Chris, Fabiola expressed interest.
Awesome. Yeah, that's what we want to hear. Yeah, any other? Definitely. So yeah, look, I'm really excited about GDevCon ANZ, and we've been talking about it, a few of us, for the last few months, and we're starting to get a bit of momentum now. And yeah, we'd love to hear your feedback or thoughts on that, and show some encouragement, and let us know that this is a good idea or not. Yeah. Well, if there's no other thoughts or questions, anyone, before we move on and let Brett take the floor? No? All right. Brett, well, let's pass it over to you, mate. This is for part 2. So what's new in LabVIEW 2022? Take it away, Brett.
All right, so this is actually more but we'll chew through that as we go. So, all right. So we'll start off collections, I guess. The first big new thing is, these both dropped in LabVIEW 2019. Palette here with maps and sets.
Sorry, Brett, your audio is breaking up a little bit on our side. I don't know if it's just our side or everyone else's.
Yeah. How's that now?
Yeah, we'll see how we go.
The manager, all right. Yeah, and I can't see the chat now, so if anyone wants to know anything, probably shout out. Would be the best choice. Looking at maps, maps are a pretty common data type in a lot of other languages. So basically a key value store, which means you have for each thing that's in the map, there's a key that goes with it. Commonly strings are used as the key, but in my example here, I've decided to use a color just to mix things up a little bit. So you can have any key you like as long as they're all the same type, and any type of thing in the map you like as long as they're all the same type. So what I've done here is just build up a map statically. There's functions for adding and removing things using the keys. As you can see, I've used just remove the yellow object and put a new yellow object in. You can also just straight overwrite them, and you get the same result both ways. So you have with 4 in there either way. You can look things up using the key, obviously. You can also convert maps into arrays pretty straightforwardly just by passing them through a for loop. So what I've got here is actually pulling out the key, and then the other values are also available there if you want to pull out the entire map as an array. That's also possible. So it was possible previously, before this dropped in 2019, to build something sort of similar using variant attributes, which I've got down the bottom here, but they were a bit more restricted. You could only really have strings as keys. And there was no easy way of getting all of your keys out. You had to keep track of them yourself, because you couldn't ask the variant attributes what the key values were. You had to know them. So yeah, this is a marked improvement over that. This is quite a nice and flexible data type. It's particularly good for settings and things like that, where you may not know ahead of time what's going to be in them. You can just sort of tag things with strings and then pull them out later on, and just pass the entire setting map through all the things that need to know about settings. You only really need to know about the parts you're going to read out.
Hey, Brett.
Yeah.
Your mouse is really loud, just saying. Every time you move the mouse, it goes over what you're saying.
Okay. Thanks. Unusual problem. Okay.
Yeah. So what version did maps and sets come in?
2019.
Maybe 2019. Right.
Yeah. Okay. So
Carry
sets
on.
are interesting. Yep. So yeah, sets are interesting. They're just basically a collection of whatever objects you like all put together. The only real proviso is that they're unique, so you can only have one of each thing in a set. Interestingly, in LabVIEW, the sets are actually kept ordered, which is unusual. Most other languages that have sets, they're just like a bag of things. They don't have order, but in LabVIEW, it's actually more like an array that's ordered as you insert things, which does come with some slight memory overhead, but it's also more performant, so that when you search for an object in the set, it's much easier for LabVIEW to find it, so it's got an idea of where it will be, rather than having to check everything that's in there. So again, I'm trying to move my mouse while I'm talking. I build a set statically, and you have insert and remove in a similar way. And there's also, because sets are ordered, you can take the maximum and minimum value out of them. Excuse me. And there's also, you can feed them through a for loop in the same way and get all the contents of your set as an array instead, if you prefer that. One other thing I'll just note in passing, you might notice that the for loop I've got here doesn't have an iteration terminal in it anymore. That's actually something, I forget when this was added, but you can turn off the I, which is nice, just so you can make your for loop smaller if they're taking up room. If you're just doing something like this that's basically got no code in it, you can shrink it right down. So that's just sort of a nice quality of life improvement. That's the result of running those. So you have a set, you can add a thing to the set, remove a thing from the set. It's all fairly straightforward. There's also, because they're sets, there's a whole bunch of maths you can do on sets, some of which you may be familiar with from primary school or high school maths. So there's unions and intersections, which are basically, the union is all the things in both sets. An intersection is all the things that only exist in both sets. So it's the AND. There's also a few other interesting ones here. A Cartesian product that creates all the possible combinations of both sets, which is sort of interesting. I'm not entirely sure of the applications of some of these, but there's obviously standard set logic type things. There's also a symmetric difference, which is basically a XOR, exclusive OR function. So you can see there the combinations of the names of each of the operators matched with the QA for both combinations. So that's sets. In networking, there's been a lot of security related things have appeared in 2020 mostly, and also 2021. So 2020 introduced TLS, which is transport level security. So this allows you to set up end-to-end encryption for your TCP/IP connections. So what I've got here, this lower level is basically normal setting up a TCP/IP connection, where you have the URL and the port you're talking to, and you just open that, and then you can read and write and close the connection. There's an extra step here, which is starting up the handshake for the transport level security. So once you've set up the certificate stuff, you hand that off to start TLS, and then as soon as that's completed successfully, you can close it and get rid of it. You don't need that anymore. So once the connection's stood up, everything's encrypted end to end after that, and you can just read and write as normal. You'll notice here that I've got a secure HTTP connection, so HTTPS, and it's also on a different port number to normal. And there was a change in LabVIEW 2021 as well, so that it now, rather than relying on some hard-coded certificates that were included with some of the tools under the hood that are used, it now uses the operating system certificate store instead, which should reduce the likelihood of having older expired certificates cause trouble, which did happen in 2020. Secure FTP is basically...
So, Brett, can I just ask on TLS?
Yeah.
What's the, is there a performance hit?
There's probably a small amount of overhead, I imagine, just from the encryption. But yeah, I haven't had any issues with it being noticeably slow, to be honest. Yeah, I imagine there is some overhead involved in it. I mean, all encryption has some amount of overhead, because you're basically doing a fair amount of complicated maths on all the data you're sending back and forth. But a lot of that will be down in the operating system, so that's probably fairly optimized. That's not something that LabVIEW itself is doing necessarily. Okay, so yeah, secure FTP is basically normal FTP, but over a secure channel. So that basically means that you're not sending your username and password in the clear, which is good. Other than that, it works pretty much identically to normal FTP, so there's not a whole lot to say about that one, apart from it's nice to have. WebSockets are also a new thing. They came in 2020 as well. So they're actually not installed by default. You have to just install WebSockets thing here. If you hit that, it'll actually go off to VIPM and load up load up WebSockets for you. It's actually a third-party tool provided by Media Mongrels. I've actually used this in a project. It's very good. And there is an additional secure layer add-on on this as well. So by default, WebSockets aren't secure. I probably should roll back a bit actually and explain what they are. So WebSockets basically piggyback on HTTP, so they work a little bit like a normal web connection, except that they're bidirectional, so that the server can send data back to you anytime it wants. With normal HTTP, you're reliant on polling the server to find out if there's anything new. So that's a bit of a performance issue, especially if you're trying to stream large amounts of data. That's not super efficient. Whereas WebSockets are a lot like using a low-level TCP/IP socket, except nicer. They can obviously use TLS as well if you're using a secure WebSocket. All the major web servers, Apache Nginx and IIS, support it and have done for about 10 years. It also supports both text and binary packets back and forth, which is quite nice. So yeah, it's a very useful tool. The secure add-on though, in order to install that, you have to go through Git and compile it yourself and put it in the VILib folder, but that's not too difficult. The Git library explains itself quite well. But yeah, it's a little bit of a bit more effort than just using the out-of-the-box stuff. There's a couple of other little things that I haven't got anything to show for. There's a couple of SHA. Sorry, yeah.
Can I just ask, does the WebSockets kind of replace DataSocket now, or?
No, I think they're meant for different things. DataSocket is an NI type streaming data protocol, I believe. Someone correct me on that. I haven't actually used DataSocket in anger. WebSockets is an open source, widely used protocol that appears in lots of other places outside of LabVIEW's universe. So a lot of JavaScript things use it. Lots of web services use it. Like that's the application I've used it for is talking to a third-party web service. So it's commonly used. It's used for audio streaming and all sorts of stuff. So it's quite high performance.
Right. So you may have just mentioned this before, but sorry if I'm asking a dumb question. But what's the difference between using WebSockets and web services?
A web service is an endpoint. A WebSocket is the protocol that talks to it. So it's like WebSockets replaces HTTP and HTTPS. So it's the actual protocol for the packets you're sending back and forth. So if you're doing a low-level TCP/IP thing, it's up to you to define what messages you're sending back and forth. This actually defines the handshaking and stuff for you. So you just send the data to the other end in a known format, and it looks after the handshaking and such for you. So yeah, a web service is basically the thing that's on the server at the other end that you're talking to. And this is actually the protocol on the wire. It's a little bit different. I don't know if that's clear at all.
Yep.
Yep, cool. Right. So I'm relying on hearing people for feedback because I can't see anything. So, all good. So yeah, there's a couple.
There was a couple of points here in the chat. Darren's raised a good point about maps and sets. That, like, whenever he starts to write some code with arrays, he pauses and asks, should we be using sets? And quite often he's using sets instead of arrays. And it's really interesting that, because I'm just so in the zone of writing arrays, I've never gotten around to using sets yet, right? Because I just go, oh yeah, arrays. But
yeah, I've actually
probably try and change the habit.
I've actually written, well, not recently, but more recently than sets have existed, than maps have existed, written the old style using variant version of it without thinking too hard. I should really have used the built-in stuff instead. But yeah, it's very easy to get into the groove of just using the stuff you know and not looking at the new stuff, this has actually been really good, because a lot of this stuff I didn't really know about before I sort of sat down and read through all the release notes properly.
Yeah.
So yeah, there's a couple of message digest algorithms which basically give you hashes for things. They're probably only relevant if you need to send a specific kind of hash through to a web service or some other thing that's expecting it. One other big thing, I guess, is the GWeb development software. That's basically all of the WebVI stuff from NXG boxed up as its own toolkit that you can use in classic LabVIEW now. So that's a kind of important tool. That's something I haven't actually used in Anger either, but Stuart's probably used or is going to use that. There's also a JSON library provided by anyway, it's another third-party add-on.
JSON text, is it?
Sorry, JSON text, yeah.
JSON text is very good JSON library. I would recommend that. Highly recommend it.
Yeah, so if you ever need to play with JSON for any reason, that's definitely use a library or something like that. Makes life very much easier. So yeah, that's another thing. If you ever do anything talking to anything out on the web, you're going to be using JSON, so it's useful to know about that. It's something we can ignore in our own little LabVIEW world, but the rest of the world uses JSON quite a lot. All right, so there's a fairly a fair number of just generally useful new VIs that have appeared in the last few years. These ones in particular I quite like. So these just create a directory or create a file, but they also create any missing directories along the way in the path, which is super useful because in the past you would have to actually check that all the parts of your path existed first before you could create the final directory or file that you actually wanted, and looks after all of that for you, which is super nice. There's not a lot to say about that, but it's really useful. These again are quite handy. The limited string to 1D array and back the other way are super useful. I've written this code myself a lot of times, just using the array to string and string to array functions. This sort of saves a bit of doing that yourself, so it's very useful. The GUID function is quite handy too. Again, if you're talking to web people, they tend to use globally unique IDs like this a fair bit, so having something that just generates it for you is nice. So what this does is basically build a random string that's due to the length and number of characters in it is pretty much guaranteed to never get repeated if someone else tries to do the same thing on another computer somewhere else in the world, like ever. So you can assign that to an object when you send it out into the world, and if it comes back with that same label on it, you can be sure that it's the same object and not a different one. So that's occasionally useful to have.
Hey, Brett, can you just go back to that one and show the help?
Or which thing? Which one are you looking at, the GUID or the
GUID, yeah. And the other VI as well.
Sorry, you didn't want the whole help,
Just a little context help. Yeah. Thanks.
Yeah, sorry, I sort of sped through these a little bit. I've been looking at them a lot the last couple of days. But basically, I should explain what they do. The first one takes a string that's delimited, in this case with commas, it could be tabs, it could be something else, and breaks it up into an array, and then takes the same array and turns it back the other way into a comma delimited string. So this is useful for packing arrays into strings, past type of things, or to dump out the text files, things like that. That sort of, it turns up a fair amount. And so array to spreadsheet string basically does the same sort of stuff, and spreadsheet string to array, but there's more arguments required, and this sort of does some of it for you, and it's more clear what you're doing. I guess that's part of the benefit of using the built-in functions, is if someone else comes along years later and wants to understand your code, it's a bit clearer exactly what's going on. If you're using a VI that's got help and it says exactly what it's for, so they don't have to guess what your intent was. Good. Okay, so the first one here just basically does what it says on the tin: remove duplicates from 1D array. Just removes duplicates, so works as you would expect. So that's down the bottom here, the bottom left of the palette. This sort 1D array has been around for a long time. This is a newer version of that. It's a malleable VI. So it works in the same way as the old one did if you don't do anything special. So in this case, the sorted array here is in alphabetical order, which is what you would normally expect. But it also has the option of passing in an optional function here, which will actually perform the sort logic as part of this VI. So you can then customize what the actual sort function looks like. So as arguments, it takes two of the same type as what's in the array, and then just returns a boolean if it's true that it's less than. In this case, I've written a little bit of code just to look at the length of the string rather than the alphabetical order, to use that to sort them by. So now if we wire this up, this is just a static VI reference to the VI here. Run that, and then sorts things by length rather than by alphabetical order. Similarly, the search, this is the old search 1D array, which is now back in the palette again. It was out of the palette and then came back again, mostly because quick drop, if you do S1D, it finds that straight away. When that wasn't in the palette, this shortcut didn't work anymore, and a lot of people were very angry about that. So the new version, there's actually two groups of array functions in here. There's an unsorted array and sorted array. So the sorted array only works correctly. So the set of functions only works correctly if the arrays are already in a sorted state when you pass them in, but they are much faster if that's true. So if you know your arrays are already in an order, that's worth using those. These unsorted ones obviously will work for any array regardless. Sorry, yeah, so this will take a set of clusters here that I've passed in. Obviously, if I'm looking for a particular cluster, and in this instance, I've got GUIDs going into them, so that each cluster will have a different UID every time it's run. So typically, if you had a whole bunch of data coming back from a connection somewhere out in the world, you might be looking for a particular set of information that's in the cluster, but maybe there's some part of the cluster you don't care about, and there's no way of searching for that at the moment, because there's no way of telling the search function that there's some parts of this I don't care about. If you make a custom search function, again, similar sort of setup to the sort one, you can specify which parts of the cluster you care about and have the match work just on what the parts you care about. Plug that in the same way. Now it'll find count for regardless of what the UID happens to be, which is handy. These two static VIs here can actually also be done with classes if you're into that sort of thing. You can actually build what is it, is equal and is less than, I think. I forget the exact names to help explain a bit better what the actual names of those are. But if you pass in an array of a type of class and it has a method that matches what the sort function is looking for, it'll use that to do the sort with, and also for doing search. So you can sort of have your own per class versions of these if that's useful as well. So I haven't found a reason to do that yet, but I'm sure that's useful if you use classes for data structures and things a lot, that would probably come up. If there's any questions about any of that. Chris, that's all good.
No questions on that.
Okay. I think there's actually a couple of things I missed that I'll just chuck in here as well. Here, of course, this one's a good one. Synchronize. Probably I don't know what the names of anything is, I just know what they look like. Okay, so synchronized data flow is super useful. So instead of having like a single frame sequence or something like that and passing wires through it in order to bring things into sync that don't otherwise have a data dependency, you can wire them through this instead, and that takes up a lot less space. So that's super nice to have. And there's also a random number function in here, which is new. So random number in range. So rather than just getting 0 to 1 as a float, you can actually say what type of random number you want. So it can be two kinds of 64-bit value, and also you can specify lower and upper bound for the random numbers you want out. So that's super useful as well, because it doesn't look like it, but generating properly random numbers with the upper and lower bounds actually correct, such that they're as likely to happen as anything else, is a bit more tricky than it looks. And it's super easy to accidentally build one where either the minimum value or the upper value can't actually happen by mistake if you don't get your scaling exactly right. So that's nice that somebody else has already done that for you. Yep.
Brett, a couple of questions. Kurt was wanting to know, what are you using to read and write maps to files?
Probably you would turn it into an array and just send that off, flatten it into strings or something like that, I guess. I haven't actually tried to get one in and out of a file yet, so I don't have a good answer for that. Apart from what you would normally do with it. I guess if you turn it into an array of clusters, you can throw it into the OpenG any file writer or something like that.
Yeah, it looks like that's the best way to do it, Brett. I was just fucking around with it.
Yeah. I haven't got as far as trying to actually store them yet, but yeah, you'd have to flatten them somehow.
Yeah, it'd be nice to store them as JSON, so pull them up and then run them back down.
Yeah, I'm sure you could probably do that as well. Yeah, I mean, once you get them into an array, you can do whatever you like with them pretty much, because there's plenty of stuff that knows how to deal with arrays and flatten them, so that's probably the go.
Yep.
if they don't support them natively, which I don't know if they do.
And just jumping back to the discussion on WebSockets, Yuri's sent a question. I'm using GWebDAV talking to WebVIs, still trying to make secure, but the WebVI connection stops working. Would WebSockets or data sockets be more suitable?
That I don't know. I haven't actually used WebVIs in Anger, so I don't know if Stuart maybe or.
Yeah, Stuart, what's the answer, Stuart?
I couldn't actually tell you that one. I have had experience, but not that in depth.
Not that particular one, yeah. Yeah, that sounds a bit specific, but yeah, I mean, yeah, I don't know. There's a lot, unfortunately, because of the amount of security and stuff that web services and the like have nowadays. There's lots and lots of ways for them to fail to connect and not want to tell you why. So unless you can get your fingers inside of the server at the other end to sort of log exactly what's going on or why it's refusing connections, it's a little bit hard to tell what's going on, because there's all sorts of rules about connecting from a different website to where the main web pages come from and all sorts of things like that. So there's cross-site injection prevention, I can't remember the right names, but there's all sorts of rules and security setups that websites and web services use to make it more difficult to connect to them nefariously, that makes it hard to do it the right way as well. So yeah, that's not very much help, but yeah, it is difficult, and there's lots of ways for it to go wrong.
Cool.
So yeah, that would require a bit more time to actually debug, I think.
Just on the data socket, Darren's just mentioned that NI recommends these days that data sockets are legacy technology. So yeah, go start a new application with data sockets anyway. Not that you were talking about that earlier, it was more than I've recognized that, but
yeah.
yeah.
They're on the palette, so it's not necessarily obvious that it's deprecated, but leaning that way. It's useful to know.
So yeah, WebSockets or network streams instead.
I mean, I wouldn't use WebSockets unless the other end was already using it, if that makes sense, because it is a bit of code to make it all work for the protocol type stuff, I guess. But all right, we're up to Python. So Python's been around since 2018. That's had a few tweaks since then, mostly, actually no, all over the place. So 2019 added the Boolean data type and also the option when you pass in an array, you can change it into a NumPy array. NumPy is a Python sort of numeric library that's used extensively, so being able to do that is obviously a nice thing. Also under that, you can change clusters into named tuples, which basically is a bit like a map. So you have a key and a value for each thing that's in the cluster. I don't know what it did with clusters before that. Maybe it didn't work with them at all. I haven't actually used it in Anger again, so I'm not sure what happened before this was added. It supports, as of 2021, supports Python 3.6 to 3.9. It no longer supports Python 2.7. So I think out in the wild, there's still a fair amount of Python 2 codes kicking around, but Python 3 has been around for quite a while now and is quite mature as well. So also that's where people would prefer to be using Python 3 point whatever. You can also pass Python classes as a parameter now, apparently, as of 2022. I don't know how well that works and what that actually does, but you can. I think that's more a thing that if you get passed back a Python class, you can then pass it to the next function in your call chain, if that's what you're doing. Some of the most important parts in actually trying to get Python to work at all with LabVIEW is you can specify which version you're talking to, and more importantly, which exact installation of Python you're talking to. Because without this path, it would default to whatever the system's thoughts on where Python was installed was, which work fine if you've only got a single version of Python installed that's the same bitness as the LabVIEW that you're using. So if they're both 32-bit, it'll work most of the time. But in my case, I've actually got 64 and 32-bit Python installed, so I've had to point it specifically to Python-32 here to get the 32-bit version. And interestingly, you have to actually point it to the DLL and not just the folder that Python's in. I originally assumed that it was just the Python directory that you pointed at, but you've actually got to say, no, this is the Python DLL in particular that you're talking to, and then it works other than that. I haven't actually done anything to make this work under the hood yet, so it calls a function, but nothing comes back, so I can't really demo this more fully than that. I haven't played with Python a whole lot yet. So I don't know if anyone's got any questions about that. There probably isn't much I can tell you, to be honest.
Oh, sorry, so from the top. No, I'm just hearing myself on the speaker. We have done, we've used Python on a project or two like this. And interestingly, like I was using it for a particular filter that I needed to apply to an image. So it was an image processing filter. And one thing I noticed is if I left the Python section open, I'd pass the image down into the Python node and it would process it as required and brings back the data. But every time I did that, LabVIEW was losing memory or accumulating memory every time. So what we had to end up doing is close the session down and open the session again, which is a pain because that's time consuming. But little things like that you've got to watch out for when you're integrating with Python.
It's interesting because I would have thought it would. Well, I guess you're crossing process boundaries, so there's no guarantee what's going to happen, I guess. But I would have assumed since you're pre-allocating, like with the anytime you pass stuff in and out of a node like this, you have to allocate in LabVIEW where it's going to go. So even if I was returning an array, I'd have to build the array first, pass it in, and then get the results out on the other side. So you're basically pre-allocating the memory in LabVIEW and then getting Python to fill it. But obviously there's something getting dropped on the floor in the process there. Yeah. I don't know if images are handled specially, I guess, because LabVIEW's handling of images is kind of a special case too, because it's all by reference. So
it's you're just passing a 2D array of numbers into Python.
That wasn't even just an image. Okay, that's a whole separate bag of interesting images. But okay, MATLAB similarly, you can talk to MATLAB from LabVIEW. I don't have MATLAB on my machine, so this doesn't do very much. But basically, you open a session, tell it what file to call, pass things in and out, get results back very similarly. So I assume that works. That's fairly new. That's only out in 2021. Most of the Python stuff's a bit more mature than that. You can get a free demo version of MATLAB though that runs, I think, for 40 days or 30 days or something like that. So if you wanted to play with it, you could. First, didn't get that far with it.
Do you have to have MATLAB installed for that to?
Yeah,
run?
so it doesn't interpret MATLAB scripts for you. It actually just hands it off to MATLAB to run and then gets the results back. It's similar to Python, so you can have MATLAB for it to work. Which, if you're in a place where you use MATLAB a lot, that's probably not a problem. There's probably licenses everywhere. But if you just wanted to fiddle with it, that's a bit more difficult. So hence, I don't think there's a free version of MATLAB, but you can get a demo version, as I mentioned, for just to play with it if you wanted to find out if it was worth jumping into. This one's fairly short. So basically, several toolkits are now 64-bit, which is nice. So FPGA runs in 64-bit LabVIEW as of 2019. The real-time runs in 64-bit as of 2022. The report generation toolkit, though, did lose some functionality in 2018, which bit me pretty hard. There's the standard format, which is basically a text-only report, no longer exists. So you've got HTML, which goes to your web browser, or Word or Excel formats. They're all fine if you're talking to an A4 printer. They don't work at all nicely with docket printers or thermal printers and things like that. So I was stuck with basically remotely controlling Notepad or printing out a device front panel to try and dump out text to a docket printer. It's not a fun experience. I think the root cause for this is though that there's some functionality which has gone away in newer versions of Windows. There's probably the cause for that. But yeah, I don't know which version of Windows actually lost that. If that has happened yet or not. So yeah, not a lot to say about toolkits there. Debugging is quite interesting. There's some good stuff in here. So this is just some fairly common demo code, I guess, for debugging. Now, normally you could do stuff like turn on pilot execution, which is really useful, but it's kind of annoying if you're going to wait for 1,000 iterations of random numbers to get generated first before your actual code does anything useful. So rather than do that, there's now a nice custom probe in here called toggle execution highlighting, which allows you to turn it on and off in between the probes. So this bit of code will just run at normal speed. The part in between the two probes will run with highlighting on, and then it'll turn back off again afterwards. So that's super nice if you're running.
That's cool.
A quite large VI and you only want to look at some of it in slow motion. That's super nice. Yeah, It's very, very, very useful. I like this one a lot. Actually tells you too in the debugging, but it doesn't tell you a lot in the debugging probe watch window here, but it does tell you what state each of the probes has turned things into. So you can see this one's turned it on, this one's turned it off. So if you've got a series of them turning it on and off, you can sort of tell what's going on if you start removing them and you're not quite sure why things are doing what they're doing. That could be useful to work out what's going on. Another nice one, history probes. Now, unfortunately, these don't work with arrays. They're not. There is an option for array types, but they are for single types. So for integers and for doubles here. So what this will do, rather than just showing you a single value, obviously it shows you the most recent one at the top and then the previous ones underneath that. And that's super nice as well. And you can, with the floating point one, you can adjust the format if you wanted to make it look a little different. And with the integer type, you can change it to be hex or binary if you'd rather look at it in that, if that makes sense as well. Now, unfortunately, it doesn't understand enums, which is understandable, I guess, but that's a bit annoying sometimes because often I'm trying to probe commands and stuff like that use enum types, and I'm going to try and work out what the numbers mean after the fact. One thing to notice too, that I've changed the type here, and this hasn't done anything yet. Same thing happens with reset history. It doesn't do anything immediately. That's not actually broken. If you run it again, the first time it hits the probe, it'll execute those things that you've changed and then catch up. But I think that's a side effect of the fact that the probes aren't actually running all of the time. They only run when they're actually, when the wire they're probing is actually doing something. So I don't know if anyone's messed with X controls at all, but part of the fun with those is that they're actually running even in the LabVIEW editor, as well as when you're actually running your code, which makes working with them a bit challenging. And they've basically completely sidestepped that in this case by not having it run unless you're actually running your code. It's a slightly unexpected behavior, I guess, if you're not thinking about it. Yeah, so this one's quite handy as well. All right.
Brett, Darren's just recommended you can very easily create your own enum history probe by right-clicking the wire, doing custom probe new, and selecting one of the existing history probes, like the U16 one, as a template. Shouldn't take long.
Yeah, that's another thing, as you've been saying about using arrays all the time. I almost never make custom probes, and I really should for a lot of stuff, particularly for long leak projects. It would make sense, but it's just something I don't think about doing.
Yeah, it's just getting into the habit, isn't it?
Yeah,
When you've been doing LabVIEW too long, you're sort of stuck in your ways.
But using the tool the same way for 20 years, you need to learn about the new stuff as well. Yeah, it's hard. It's very easy to get into a groove and just do the same thing. So this is interesting. There's a new feature with errors. You can actually get multiple error values into a single error cluster now. It's kind of interesting. The documentation for it's a little bit light on, though, I found. So let's close this up. If we look in the detailed help for these, it tells you what it does. It doesn't say anything about how to use it and what to expect, I guess, if that makes sense. Like there's no overview type documentation. It just, each thing, it basically restates what the name of the VI is in slightly different words. So it took me a little bit of a time to work out how to use them and get it to actually work right. But they are useful, I think. So what I've got, this lower VI here is just a normal merge errors VI. And how this behaves, if you have an error in, say, the top cluster has an error code, that will get passed out of error out. Any other errors underneath that just get lost. So if you send multiple errors into it, only one of them will actually make it out the other end. There's a new setting here in the quick menu. If you pop that open, to retain all errors, and that actually changes what it looks like. So it looks like the one above here now. So rather than picking the first error that it sees, it keeps all of them. How it does that is that the error codes aren't duplicated, but it basically takes the code, the status, and the string and packages it up as JSON. It puts that in the source string, and then if there's more errors, it just makes a big array of JSON strings and puts them all in there. And then you can sort of pull that apart later on to actually get sense out of it. I'll explain that a little bit in a moment. And you can, interestingly, also add custom attributes to the errors as well. So not only do you have status code and your text, you can add other random attributes to it as well. Like I've just thrown style in here as one just to test it out. So you do have to encode the string that you pass in as JSON for it to work as well. If you pass in just a raw string with no quotes, it doesn't work properly. So that's something to be aware of too, that you do actually need to be throwing JSON into this as well. I did also find that if there isn't an error on the wire, the attribute gets lost, even though I would have thought that a not error is still an error. It's just an error of code 0. The status is off, but apparently the attribute doesn't seem to stick in that case. I don't know if that's by design, but it caught me out when I was testing stuff. We're going to run this again. You can sort of see what it's done. So I've just got a loop here, just generating errors. So we have this wire here has what you see in the error cluster here. So it's just a single error code. So I think the first error code is still propagated. So the new 5001 errors aren't visible immediately, but they're all encoded in the JSON inside of here. They're all, you see, all packed in there. If you want to actually make that make sense, you pass it through error cluster to array of errors. That takes that and turns it into an array. So it turns it into an array of the same type of thing. So it basically takes the JSON and splits it up into separate clusters, but it's still JSON encoded. So if you want it back to traditional error messages, error cluster, sorry, you need to pass it also through convert to legacy error cluster, and then it comes back looking more like what you'd expect. And then you have out of one error cluster unpacked an array of error clusters here with all of the individual errors in. So it does work quite nicely once you work out how to drive it. It's a little bit unclear, I find. I think that's mostly documentation at the moment.
Okay.
And then pull out the actual attributes based on that. So I've only got one here at the moment, the style, and then it pulls out the attribute as JSON. So yeah, I haven't tried using this in a real project yet to see how well it actually works, but it seems to hold together pretty well just for demonstration purposes. I assume it's pretty well.
So is this 22 this came in?
It is. There's 2020 actually. It's older than I thought.
Can you just scroll back to the left a bit? Just talk me through the JSON stuff. I didn't quite get that when you were talking about that earlier.
Yeah, so basically this is the normal merge errors cluster, or VI. That just gives you a single code out. This one started out life as the same one, except I turned on retain all errors.
Yeah.
What it does is when the second error comes in, it packs that as JSON into the source text. So in here, you've got JSON text, so that's got a description of what the JSON is here at the front, and that starts an array.
Right. Okay.
In here anyway, but basically you've got an array of JSON strings, so one for each error that it's collected. And as you add more errors to the cluster, it just appends to that string. So it means that the error code that's on the error cluster, as it goes through the following VIs down here, still remains 5000, even if you add other codes to it later. So that won't change, but the actual error messages from them and the details of it are packed into the string, and you can get them back out. So I don't know quite how that's going to play with trying to pull particular error codes off the wire when you handle them in different ways. Actually, there's something here I sort of skimmed past as well. There's a slight change to the way clusters, case statements deal with error clusters now. So it used to be the case that you'd have no error or errors due to cases if you write an error in. Now you can actually have specific errors.
Yeah.
It behaves like a sequence of numbers. So you've got error 9 here, and you can have anything from 9 up. So it works the same as what it does with integers and things like that, where you can have a sequence. So you can say up to 0, 1, 2, and then 3 onwards. There's several different cases that work similarly to that. So you can have specific error cases for particular errors without having to do any code to have it happen, basically. Just a configuration.
I think just back on your comment there, the error response would be just whatever the first error was, let's handle that one. And then you've got all the other information as secondary. You still want to handle that first error that happened.
Yeah, so well, it depends a bit, I guess. It depends how complicated your error handling is, exactly what you do and when you do it. Yeah, I mean, by default, LabVIEW leans towards as soon as there's an error, just throw your hands up in the air and stop doing anything. But that's not always what you want to have happen, I guess. So yeah, it depends how complicated things get. But yeah, I mean, it works pretty nicely though. If all you want to do is collect information about other areas that might get otherwise lost.
Yeah. Hey, Brett, just to let you know, we're coming up to 1:30, so
Yeah. All right. Well, I might skip interfaces because that's probably a whole talk on its own. I'll very quickly show interfaces because they are very nice, but they're kind of, you need to be a person who writes object-oriented LabVIEW code to care about them. So I'll skim through this super fast. So basically, by default in LabVIEW, you only get single inheritance, which means that each class can only have a single parent. This is good because it avoids diamond pattern problems you can get with multiple inheritance, where if you inherit the same method from multiple different parents, you don't know which one's going to get called, and that's not good. Interfaces allow you to add sets of methods to your class without inheriting an actual implementation of the method, just the name of it basically, and the arguments. So it's, in my example here, it started out with a cat and a parrot, so you had an animal that could walk, an animal that can fly, and that was pretty straightforward. But then if you add to that an animal that flies, an animal that walks, and a bird that walks, and a bird that flies, suddenly your hierarchy gets all messed up because you're trying to have different methods that belong in parent objects that don't fit in the right place. Anyway, it's just too complicated to try and explain quickly like that. Basically, it allows you to have almost multiple inheritance with none of the downsides of it. Super nice. The only thing to know, I guess, is that when you inherit from a interface instead of a class, you actually have to implement all of the methods on the interface yourself. So you can't inherit run from, say, cat here. So the cat actually has its own run method because it inherits from terrestrial. So this class would actually be broken if you didn't have that. It's very quickly. So inheritance has now got a single parent class, but you can have as many interfaces as you like. So you can add one or many of those. So yeah, interface is really nice. Good if you're doing object-oriented programming, it makes designing classes much nicer.
Interfaces came in LabVIEW 2020, and there's some really good presentations on YouTube by Google Loftus Mercer. Check that out to learn more about it.
But there's quite a bit of background knowledge to have before it even makes sense to you, so it's probably too hard to go into in depth. This is just a couple of really nice sort of quality of life changes that have appeared. There's a little arrow here. I don't know if you can see that in the corner of the text box. So if you have a single line text box and there's more text than you can see, there's a little marker to indicate that. Interestingly, the marker goes away if you have a bigger than one line box, even though the text doesn't fit, which is interesting, but it works great if you've only got a single line one. For both cases and enums, also other rings and such, if you have a lot of cases to search through, there's actually a search box for it now, which is great if you've got tons and tons. So rather than scrolling up and down a big list trying to find the one you're looking for, you can just search for it like that. That's super nice. Same thing with this one. And one final thing. This is just a VI I've thrown together. There's all these indicators and controls are widened into the connector pane as usual, but the front panel is a bit of a mess. There's a really quick way of fixing that. It's a quick drop. You hit Control Space and Control F. And it goes and puts it at the top left of the main monitor, which is not super helpful in this instance. But it comes back and everything's laid out nicely, so the indicators line up with where they are on the connector pane. And you can also set icon to name, and it just throws the name of the VI up there as text. It's super quick and easy, so they're just nice things as well, and that's it. How's that?
Awesome. You know what, though? I definitely want to know what's in. Don't look in here.
What's inside of there? Untitled.
Oh, is that it? There'd be something more exciting.
I was doing some experimentation with maps actually. No, sets, sorry, just with sets, because it says in the help that they're actually supposed to be quite fast. And I threw 10 million random integers into one and also into an array, and it was about 10 times slower, which surprised me. But I think maybe that's a corner case and it's not that bad usually, but yeah. That was just something I didn't touch on, the performance of the newer collections. but I don't know if people often have sets of that many things.
Right. Well, thank you, Brett. Is that it?
It is. There was a couple of other things that don't have slides, but they're nothing super important there, I think. There's stuff in builds and such, but I won't touch on that because it'll take too long.
That was really good. I'm glad we sort of covered more than just 22 because there's a bunch of little stuff that, you know, from 18 onwards that have crept in. So it was really helpful.
Well, interestingly, I think, I'm not sure if that's true for 2021, but certainly 2022, I couldn't find upgrade notes for. So all these older versions of LabVIEW, there's a standard way of finding the upgrade notes for them, which are really good. They have a big list of all the things that are different and new. So they're useful to have a look through. But they don't seem to exist for the newer versions for whatever reason. I don't know why. So I don't know if Darren has any insights about that. But yeah, either I was looking badly or I couldn't find them. I'm not sure, but they don't seem to be, they're certainly not laid out in the same way and not in the same place.
Yeah, I left LabVIEW R&D when LabVIEW 2020 released, and everything just went downhill after that. So yeah, who knows what they screwed up after I left.
Fair enough.
Absolutely, Darren. Jeez, we need to phone you, mate. That was really good, Brett. Thank you. Has anyone got any questions for Brett? There's been plenty of feedback along the way, Brett. A lot of people just saying thanks now in the chat. So yeah, thanks from Karina and Michael, Wiley, everyone's saying thanks. So yeah, good effort.
It was a good learning experience to actually go through it all because, as I said, I haven't actually looked at some of these myself in depth, so it was good.
Yeah, definitely. I'm keen to go and buy some other stuff now. All right, well, let's. We've gone past the hour, and I guess everyone's probably going to get back to their days, so we'll wrap that up now. And yeah, awesome to get back and happening the LabVIEW User Group. So appreciate everyone for attending today. Can I just remind everyone that that I've put the URL in the chat. I'll just put it here again. Please, if you haven't already, we'd love it if you could go and jump on the survey and give us your thoughts. Be really appreciated. I've just added it to the bottom of the chat there. Yeah, we'd like to get some good feedback from the community on how this should go. And appreciate you being in here, Darren. It's really awesome that you could make it.
You must be kind of late.
I've always been a night owl. This is not late for me.
Too bad.
All right, let's leave it there, guys. Thank you for attending, and yeah, make sure you book in for GLA Summit next month. And yeah, it's a wrap.
Thanks, everyone.